And we're back. In this video, we're going to talk about half-angle identities. We're going to derive them, state them so we know them, and then we will use a half-angle identity to calculate an exact value for an angle that is not on the unit circle, but maybe is half of a unit circle value. So half of 45 is 22.5. Half of 30 is 15. So this just really gives us a way to find exact values for more than just the values we know that lie on those 30, 45, 60, 90 degree or radian measures in the unit circle. So in order for us to derive it, we are going to start with a cosine double angle, and there are three. But I'm going to write cosine 2 theta is 2 cosine squared theta minus 1. So this is an identity that we know. And I'm using a double angle because I have 2 of something and 1 of something there. And 1 is half of 2. So what I'm going to do is I'm going to take this theta and I'm going to refer to it as half of an angle. So I'm going to say let theta equal alpha over 2. And if that's the situation, what is that going to do for 2 theta? Well, that would mean that 2 theta is 2 times alpha over 2, or 2 theta would just be equal to a singular alpha. So I'm going to sub in that alpha over 2. I have cosine 2 alpha over 2, and so all of that is in my cosine argument, equals 2 cosine squared of alpha over 2 minus 1. So this simplifies, as we set up here, 2 times alpha over 2, that's just going to be alpha, so I have cosine of alpha equals 2 cosine squared of alpha over 2 minus 1. So there I see half of an angle. I've got an angle measure cut in half, divide by 2. So I want to isolate this, which means I'm going to add the 1, divide by the 2, and then take the square root. So I've got cosine alpha plus 1 over 2 is cosine squared of alpha over 2. Isolating that term, I'm going to end up with plus or minus the square root of cosine alpha plus 1 over 2. And that is equal to cosine of half some angle. So personally, I don't store this in my brain. I just know that if I had some 30 here, then that would be a 15. Or if I had some larger angle, I could put my half angle in here to calculate what that value is. Does that make sense what I'm saying? A half angle is really a double angle identity. It's just a different way of presenting it. So this is one half angle identity. Now I want you to notice we've got a plus or minus in front of that. So when I have this squared and I use a square root to solve, I have to put that plus or minus here. And you're saying, well, how do I know? What is it plus or minus? You would choose that plus or minus by looking at the quadrant. So now let's state the identities. The other two, the sine and tangent of alpha over 2, the half angle identities, those are pretty easy for us to derive in a similar manner. But I'm just going to go ahead and write them for us on the next screen. So we have 3 half angle identities that we want to know. I'm going to say sine of x over 2. It could be alpha over 2. A variable is a variable as long as you know what it means. So sine of x over 2 is going to equal plus or minus the square root of 1 minus cosine x over 2. Cosine of x over 2, which we just derived, looks very similar. It's plus or minus the square root of 1 plus cosine x divided by 2. And tangent, if you know sine and you know cosine, tangent is the ratio sine over cosine. And if I put each of these in a fraction over each other, these square roots would combine into just one really big square root. Those denominators would cancel, and we would be left with tangent of x over 2 is plus or minus the square root of 1 minus cosine x over 1 plus cosine x. And using a small amount of manipulation, algebraically rationalizing this expression, multiply by 1 plus cosine x over 1 plus cosine x, or vice versa, multiply by 1 minus cosine x over 1 minus cosine x. We could derive sine of x over 1 plus cosine x, as well as 1 minus cosine x over the sine of x. So these are two other versions. So we've got 1, 2, 3, 4, 5 half angle identities here on the screen. And I tell students you don't need to have each of these stored on the test. If I ask you to compute a half angle exactly and use the formula, I'll give you the formula. But you do need to be familiar with them. So we have learned several identities so far. We've learned a set of Pythagorean identities, and we said we have 1 sine squared plus cosine squared equals 1, and we can turn that into 8 others, so 9 versions of the Pythagorean identity. We have double angle identities. We have 5 of those, and then we also have our sum and difference identities, which are 6 identities, but we write them as 3. So just a little reminder, what you need to know your Pythagorean identities, your sum difference identities, as well as your double angle identities. These you just need to know how to use. So let's do one problem in this video where we use a half angle identity to find an exact value. So for this example, we're going to find the exact value for this trig expression, and we're going to use a half angle identity. So we're dealing with sine, which says, hey, we need to know our sine half angle. And as we just wrote, sine of x over 2 is plus or minus the square root 1 minus cosine x over 2. All of that is under the radical. So what is sine of 5 pi over 12? And in order for us to do this, we might need to think, well, what is 5 pi over 12 half of? Maybe it would help us if we turned 5 pi over 12 into degrees. So 5 pi over 12 times, turning this into degrees, we'd multiply by 180 over pi. So that is 5 times 180 over 12. And that conversion gives us 75 degrees. So we're being asked to find sine of 75 degrees. Well, what is 75 degrees half of? 75 is half of 150. And 150 is a measure on my unit circle. So I'm going to let my half value, x over 2, be 75. and x is going to be that 150. So the way we would write this is to say sine of 75, because that's my x over 2, is plus or minus the square root of 1 minus the cosine of 150 over 2. So we just need to calculate cosine of 150. Cosine of 150, thinking about our unit circle, 150 is reflective with my 30 degrees, and my values are going to be root 3 over 2 1/2. So this would be negative root 3 over 2 positive 1/2. So working through this problem, sine of 75 is plus or minus the square root of 1 minus negative root 3 over 2 over 2. So this value came from 150 degrees on my unit circle. And because I know 30, I can reflect it across and just negate my x value. So this, simplifying this, we've got plus or minus the square root of 1 plus root 3 over 2, or plus or minus the square root of 1/2 plus root 3 over 4, plus or minus the square root of 2/4 plus root 3 over 4, plus or minus, adding those numerators, I have 2 plus root 3 over 4. I can take the square root of 4. I have that sine of 75 degrees is plus or minus 1/2 square root of 2 plus root 3. And we have this plus or minus. There's really not much we can do to simplify this anymore, but the plus or minus, we would choose that sign based on the quadrant. Which quadrant is 75 in? 75 or 5 pi over 12, those are in quadrant 1. They're coterminal. So in quadrant 1, everything is positive, and of course we would use the positive value here. So sine of 5 pi over 12 is 1/2 root 2 plus root 3. That's my final answer. I'm able to find this exact value. Of course, I can type this in my calculator and get a decimal approximation, and either in radian mode, typing sine of 5 pi over 12, or in degree mode, typing sine of 25, you would get a decimal value 0.9659258263. That's what exactly shows on the calculator, which is a decimal approximation. And if you type this into your calculator, you'll get that same decimal approximation. So, this is just a way to find an exact value inside our computations. So again, the half angle identity, it's not as important, but you do need to be familiar with it, and it does show up a little bit in your future calculus classes when you're simplifying problems. So that's it for our identities. So in the video following this, we will talk about proving. So I will give you a trig equation, and you're going to manipulate it and show me that it is true just using common, algebra skills, GCFs, factoring, substitution of identities, simplifying. All of that's going to come together. All right, so now we'll be able to use what we're dealing with.